Okay, we're going to pick up where we left off last time. Remember that last time we started with 2 points on a graph in a straight line through those 2 points. We wanted to determine the equation of the straight line. And of course, there are various ways to determine the equation of a straight line, point slope form, 2-point form, etc. Okay, but we're going to use the form y equals mx plus b. And instead of using those methods, we use a method we've already seen just to lay the foundation. Okay, we use the equation y equals mx plus b. We plug the coordinates of the first point into the equation, and we get an equation that has m and b as unknowns. But the coordinates are x and y. The equation is y equals mx plus b. If we replace x and y by the values at a given point, then we're only left with m and b as unknowns. We have a second point, and we can do the same thing with it, giving us a second equation with m and b as the unknowns. Then it becomes easy to determine m and b. Now, a method we probably used earlier is since y equals well, let's not even mention that. Okay, that would involve writing stuff down. I don't want to do that. Divert attention. Okay, so we have the two equations. We write them again in the form negative 6m plus b equals 7, with the m and the b, the unknowns, on the left-hand side rather than on the right-hand side. And we write them with the m terms one above the other, okay, vertically aligned. And the b terms are vertically aligned. The equal signs are vertically aligned, and the numbers to the right of the equal are vertically aligned. Okay, we number the equations 1 and 2, and then we go through a series of steps, which we documented previously, and I'm not going to go through those steps again. But essentially, we multiply the second equation by 2 so that the 3m becomes a 6m and aligns with the negative 6m in the first equation. So when we add the equations, m goes away and we get a solution for b. We took our solution for b, plugged it back into the original equation, either one of them, and we solved that equation for m, and we got the equation y equals 11/9 x plus 13/3. On the graph, we noticed that the rise from the leftmost point to the rightmost point is 17. The run is 9, so that the slope is 17/9. And of course, that agrees with the value we got for m when we solved the system using this method of elimination. We call the method that we use the method of elimination because we have eliminated one of the variables by adding multiples of the two equations. And that's pretty much what we've done. Now, we then wrote an abbreviated version of the process. We conducted an abbreviated version. Equation negative 6m plus b equals negative 7 was represented by a row of a matrix. Between a set of brackets, we had two rows. The first row had the numbers negative 6, 1, and negative 7, which were the coefficients. Negative 6 is a coefficient of m. B has a coefficient of 1. And to the right-hand side of the equal sign, we had a negative 7. The second equation, 3m plus b equals 10, had coefficients 3, 1, 10. So the second row of our matrix was 3, 1, 10. We then added multiples of rows to other rows and did some operations. And we ended up with the matrix 1, negative 1, 6, 7, 6 for the first row, 0, 1, 13/3 for the second row. Every operation we did was either multiplying a row by a number or adding two rows. Adding two rows corresponds to adding two equations. If the equations are valid, then when we add the two equations, we get a valid equation, an equation with the same set of solutions as the original pair. Okay, so we conclude from the second equation, well, the row 0, 1, 13/3, 0 is a coefficient of M, 1's a coefficient of B, 13/3 is to the right of the equal sign, 0, 1, 13/3, therefore corresponds to the equation B equals 13/3. We could then substitute that back into, we could substitute back into one of the original equations, but we substitute it into the first equation that we ended up in the last step and solve for M, and we get M equals 17/9. B equals 13/3, M equals 17/9, totally agrees with the M equals 17/9 and B equals 13/3 that we got when we used multiples of the rows of equations. Okay, now we're going to go on with the method of elimination and talk a little bit more about it and how it can work out and be of value in analyzing a number of situations. Okay, we have a system of three equations here. The equation I've numbered one, numbering up one with a circle around it, is 2x plus 3y minus 4z equals 9. The second, number 2, put a circle around the 2 next to the equation. Put the equation as 6x plus 7y plus 5z equals -1. And then third equation, circled 3, numbering the equation. That equation is x plus 2y plus 3z equals 0. Now I want to solve that system. First thing I'm going to do is I'm going to rewrite the system. I'm going to put equation 3 as the first equation, then equation 1 and equation 2 as the second and third. You'll see why I did that in a minute. So first equation was x plus 2y plus 3z equals 0. The second equation was, or the first, okay, the third equation was x plus 2y plus 3z equals 0. That goes in the first, that's the first equation in my second step here. Okay, equation 1 was 2x plus 3y minus 4z. That'll be the second equation now. That's 2x plus 3y minus 4z equals -1, equals 9. Look into the second equation. Gotta watch my eyes here. Okay, that works out. That's okay. And then the third equation will be our old equation 2, which is 6x plus 7y plus 5z equals -1. Now I can do things here. Okay? I can, if I multiply the first row by -2, I'm going to have a -2x. And then I'm going to have some other stuff, but the -2x is what I want to look at, because if I then add the first row to the second row, which has a 2x, I'll have a -x plus 2x. My x's disappear. Then I could add 3 times the first row, 6 times the first row, -6, I'll get it right, -6 times the first row to the third row in my new system. Okay? So -6 times x would be -6x. And add that to the 6x in the third equation of my new system. It's going to give us 0. You know, it just occurred to me, there's some ambiguity in my notation here. I've numbered the first equation 1 because it was equation 1 from before. Second equation, I'm sorry, I've numbered the first equation 3 because it was the third equation in the previous step. Okay, so I'm going to do this. I'm going to say the third equation becomes the first equation. So I've rewritten what is to the left, or my label for the equation x plus 2y plus 3z. It was the third equation. It's now the first. Okay. Then equation 1 from before becomes equation 2. And equation 2 from before becomes equation 3. So now I see what equation each of my 3 new equations came from. And I've got the new number for each of these equations. Okay. So the equations are now numbered 1, 2, 3. But equation 1 was the previous equation 3. Equation 2 is the previous equation 1. Equation 3 is the previous equation 2. I think that'll help us keep better track. Okay, well, now what I want to do is I like my first equation. It has a 1 in front of x. And I want my first equation to have a 1 in front of x. So I'm just going to rewrite equation 1 from before. Now I'll write equation 1 remains equation 1. So I'll write equation 1, little arrow, circle equation 1 again. Okay. Equation 2. Okay. Is going to be obtained by adding -2 times equation 1 to the old equation 2. So I'm going to take -2 times my previous equation 1 and add it to my previous equation 2. That'll become my new equation 2. Now, I'm not going to write that equation out because it takes a little figuring to add -2 times an equation to another equation. And I don't want to do that in this column. I want these columns to very naturally without a bunch of side calculations and stuff. But that's what I'm going to do. And that's going to eliminate the x here. So I know in advance that I'm going to get a 0 in the first column. The first number in the second row will become 0. Then if I do -6 times equation 1 added to my old equation 3, -6 times the old equation 1, which started with just an x, -6 times equation 3, which had a 6x. It's going to give me a -6x and a 6x. It's going to give me a 0 here. Now we've got to figure out what else goes in each of these rows. What else goes in each of these equations? So let's see. -2 times equation 1 plus equation 2. Let's do that over here. Okay, -2 times equation 1 is what? -2 times x is -2x. -2 times 2y is -4y. -2 times 3z is -6z. -2 times 0 is still 0. Equation 2 is 2x plus 3y minus 4z equals -9. If I add those two equations, I get -2 times equation 1 plus the old equation 2. -2x plus 2x gives me 0. -4y plus 3y gives me -y. -6z minus 4z gives me, make sure I've got my numbers right, -10z. That gives me -9. Okay. And it shouldn't be -9 because when I copied my second equation down here from my first equation had a 9 on the right-hand side of the equal, and the negative slipped in there. My hand must have done it. My brain wouldn't do that. Okay, so I recognize that I should not have a -9 here. And that should equal 9. Okay. Correcting an error that I happened to see. If we'd have gotten all the way through the problem and checked the solution, we'd have found out that something had been screwed up. I'd have gone back here and seen what I did. Eventually, have to do some detective work, long process to figure out where the error is in one of these problems. Okay, which makes it a little bit challenging. Okay, in any case, we see that -2 times the equation 1 from the second step plus equation 2 from that step gives us 0 minus y minus 10z equals 9. So we're going to have 0 minus y minus 10z equals 9. Then my third equation, well, I've got to do -6 times the first equation plus equation 3. So -6 times the first equation. Now that instruction is written in the third step, meaning equation 1 is equation 1 from the second step. So -6 times this equation, -6 times x is -6x. -6 times 2y is -12y. -6 times 3z is -18z. And that's going to equal 0 because anything times 0 is 0. And then I'm going to add that to the third equation from my second step, which is 6x plus 7y plus 5z equals -1. I add those up, -6x and 6x gives me 0. -12y plus 7y is -5y. -18z plus 5z is -13z. There's something wrong there too. I'm going to have to figure that out. And that equals, see what I did? I don't think it's going to help. Okay, I pretty much did everything wrong when I multiplied -6 by equation 1. Started multiplying numbers that appeared in my head, and I'm not even sure where some of those numbers came from. Okay, let's do it again. -6 times the numbers in the first equation. -6 times x gives us -6x. -6 times 2y gives us -12y. Oh, that was right. And -6 times 3z. Well, I thought I'd done something wrong, but I didn't. -18z. Copy this equation down correctly. -5y minus 13z equals -1. Now I know there's a glitch here, okay? And I know what the numbers are supposed to be, so I want to take a minute and step back and see if I can fix that. Okay, all these steps are correct for the equations that I wrote down. When I copied this equation down and I worked out these equations so they come out with a nice solution and don't get into a bunch of complicated fractions. That happens, but we don't want it to happen now. Anyhow, I misread a 2 and wrote it as a 7. I should have a 2 here. Or have a 7y, I should have a 2y. So when I have the 7y here, it should be a 2y. Then -12y and 2y will give me -10y. And there's something else wrong. I think that I should have had a negative 2y. Where the 7 is a 2 in the negative. Okay. Apologize. Unfortunately, I only got time to do one take of these videos. So my 2y should have been a negative 2y here and here and here. Okay, now, still doing the same step because my negative 6 times equation 1 was correct. My equation 2 from here, which was equation 3 here. My equation 3 here was copied from my equation 2 before, which had a 7 where I should have had a negative 2. Yeah, the negative and the 2 probably got smushed together, at least the way my eyes picked it up, and came out as a 7 originally. Okay, so with those changes, none of what I've done so far needs to be changed. All the steps I've made are correct up to this one right here, where I had the wrong equation. So negative 12y and negative 2y is negative 14y. Negative 18z and 5z is still negative 13z. And this equation is correct. And then I put 0, although I don't really need it. So what I get now for my third equation is 0 minus 14y minus 13z is negative 1. Now, what have I accomplished? I've eliminated x from the second and third equations. In my first step, I noticed that I had just a plain x here, so I chose to make that my first equation. So that x would remain, well, I get zeros below it. Okay, the next thing I want is, I really want a 1 here where I have the negative y on my second equation. I've got zeros here and here. I want to have a 1 here. Okay, so in order to get that, I take my third equation, my second equation. Okay. First of all, I'm going to copy down my first equation. I'm not going to change it right now. My second equation, I take negative 1 times my old second equation. And that becomes my new second equation. And my third equation is still my third equation. So the only equation I'm going to change is the second. And that's going to be 0. I'm multiplying everything by negative 1, so all my negatives become positive, and all my positives become negative. I get 0 plus y plus 10z equals negative 9. And my third equation stays 0 minus 14y minus 13z equals negative 1. Well, now, I'm in danger of the whole lab by moving the board over a little bit. Yeah, we'll support 400. I don't know why the thing sticks there, but it's okay. I'm not leaving myself an abundant amount of room, so I want to move over. Should be stable. Okay. Now I've got this system here, which I'm going to continue over here. The next thing I'm going to want to do is I'm going to keep my equation 1. That's x plus 2y plus 3z equals 0. I'm going to keep my equation 2. My equation 3, I want a 0 where that negative 14y is. So what I'm going to have to do, get just a little more room here. What I'm going to have to do is I'm going to have to add 14 times the second equation to the third, because if I multiply everything in the second equation by 14, my y will become 14y, and that will match up with the negative 14y in the second equation to eliminate y. Okay. I'm going to complete my labeling up here. Again, when I wrote down equation 1, same as the old one, I write equation 1 becomes equation 1. My second equation is negative 1 times the old second equation, which becomes the new second equation. By equation 3, I'm going to write 14 times equation 2 added to equation 3 becomes my new equation 3. Okay, so let's look at adding 14 times equation 2 to equation 3. I'm going to do that down here, not on the column that I'm going to get when I do these operations. But I'm going to say, okay, negative 14 times my old equation 2. I got 0 plus y plus 10z equals negative 9. 14 times 0 is 0. 14 times y is 14y. 0 times 10z is 140z. 14 times negative 9 is negative 126. I need a little more room to write that out, so I'm going to write it out again. I think I'm safe writing it down here. 14 times equation 2. This isn't going to extend all the way down to here, I hope. 14 times equation 2 is 0 plus 14y is 140z was negative 126. Then equation 3 is 0 minus 14y minus 13z equals negative 1. So that's my equation 3 from this step. I add these, I get 0 plus 0 minus 117z it's 127z, sorry. Equals negative 127. So now I have 0 plus 0 minus 127z equals negative 127. Okay, well, that's convenient because this is an equation I can easily solve for z. Solve equation 3. (127z) equals negative 127z equals negative 127, so z equals 1. Then plug the solution into equation 2. It's 0 plus y plus 10z equals negative 9 becomes y plus 10 times 1 equals negative 9, which has solution well, that can't be, something went haywire there too. Take a look here. We can finish it, but I wanted to get nice numbers, and I'm not sure I'm going to get them this time. Okay, it's a good thing, probably, that I'm checking myself as I go. 140z minus 13z is plus 127z. So we have plus 127z, which gives us z equals negative 1. Okay. Now plugging this solution in here, I just about have it right, but I have 10 times 1. I have the wrong value for z. Should be 10 times negative 1 equals 9. And that is a very simple equation that has solution y equals 1. Okay, sorry for the errors, but not being as careful as I ought to be. You see that you have to be very careful with these things. Also, as it turns out, I'm not seeing all the details here. I'm having a little problem with the board, so give me a second. Any luck, the whole thing will collapse in a minute. And I can slide this one. Okay, now I believe we can see everything. I think, yeah. Okay, now all that was missing over here was where I did the operation 14 times rho 2 plus equation 3. 14 times rho 2, 14 times 0 is 0, 14 times y is 14y, 14 times 10 is 140, so we have 140z, and 14 times negative 9 is negative 126. And then the third equation, that was the third equation from this step. 0 minus 14y minus 13z equals negative 1. When I add these two equations, the negative 14y and the 14y give us 0. 140z minus 13z gives 127z. Negative 126 and negative 1 give us negative 127. And that is my equation 14 times the old equation 2 plus the old equation 3 becomes the new equation 3, which is what we got down here. 0 plus 0 minus 127z equals 127, maybe 127. That should have been plus 127z. Make sure it's corrected. And now this equation we solve, 127z equals negative 127z equals negative 1. We plug z equals negative 1 into the second of our new equations. And we get y plus 10 times negative 1, 10z is 10 times negative 1, equals negative 9. And we solve that. Now these three dots here mean just do the obvious, add negative 10 to both sides. You get y equals 1. Okay, now, plug y and z into equation 1. Equation 1 is x plus 2y plus 3z equals 0. Don't know x yet. We just found out that y is 1 and z is negative 1. We get this. This gives us x plus 2 minus 3 equals 0. So x equals 1. 2 minus 3 is negative 1. Add 1 to both sides. We get x equals 1. I don't have room to write that, so we'll fudge a little bit. So enough room to write it. Gives me x equals 1. And I'll do my label this. So that I haven't changed what I'd written before. Okay, well, what we see now, we found that z equals negative 1. We found that y equals 1. We found that x equals 1. Okay, so the solution to the system is x equals 1, y equals 1, z equals negative 1. Now, the original system, which I'll copy down, well, actually, the original system was in a different order. It was 2x plus 3y minus 4z equals 9. It was 6x. Well, I'm looking at the wrong place. No, I'm not. Okay. 6x minus 2y plus 5z equals negative 1. And then it was x plus 2y 3z equals 0. We've verified that plugging 1, 1, and negative 1 into this equation gives us 0. And I thought that I just written that out. Apparently not. I felt like I plugged it in. Okay. This gives us for x equals 1, y equals 1, z equals negative 1, we should get 2 times 1 from the first equation. 2 times 1 plus 3 times 1 minus 4 times -1 equals 9. Second equation should be 6 times 1 minus 2 times 1 plus 5 times -1 equals -1. Equation should be 1 plus 2 times 1 plus 3 times -1 equals 0. And we can easily see that all those are true. Okay, first equation, and just so don't block the board too much, becomes 2 plus 3 minus 4 plus 4 equals 9. 6 minus 2 minus 5 equals -1. And 1 plus 2 minus 3 equals 0. Well, 6 minus 2 is 4. Subtract 5, you get -1. 1 and 2 gives you 3, minus 3 gives you 0. 2 and 3 gives you 5, add 4, you get 9. Big old check mark. Okay, now that was fairly tedious, fairly long, and there were a couple of mistakes. Made it a little bit harder to follow, maybe. But just kind of review what we did. And see if you can work it out yourself. Okay.